When you were in Math 1 or in Math 8 Honors, you looked at the scenario where you had two parallel lines cut by a transversal. And you had all kinds of angle relationships. You had vertical angles, you had alternate interior angles, alternate exterior, corresponding same side interior, same side exterior. There are all kinds of things that you guys looked at. I want to narrow in on a couple of those that are going to come up again with proving triangles congruent. And the most common two are listed here. And so it says if two lines are cut by a transversal and we're dealing with parallels, okay, then alternate interior angles are congruent. And then also the second one, that corresponding angles are congruent. And what's important for you to remember and to apply here is when you look at a pair of alternate interior angles, so for example, angle 3 and angle 6, we say they're interior because they are they're in between the two parallel lines. We say they're alternate because they're on opposite sides of what we call the transversal, the line that cuts through there. But the thing that you want to pay attention to is those angles are connected. Every angle is created by two segments, and the two segments that create those angles are the parallel line and the transversal. So that angle has to be touching the parallel line. Okay. If you look at corresponding angles would be, for example, angle 6 and angle 1, because they are in the same corner. The 6 is in this intersection here. The 6 is the top right-hand corner. In the second intersection, 1 is also in the top right-hand corner. Those we would say they're corresponding. They're in the same general location, and we also get congruence there. But again, they are both touching the parallel line and the transversal, and that will again be an important thing to bring up. So let's start with number 2. Okay. We have a little bit of notation here. In the given, it says BA, segment BA is, we have these two vertical lines that are right next to each other, and so that's a symbol for parallel. It's a segment CD. And when we mark that on here, so BA, we use arrows to indicate parallel. So BA is parallel to CD. And I think actually you have another statement here that I don't have, right? You also have that BC is parallel to what? AD. Okay. And I'll mark that in a second. But whenever you have parallel lines, it's going to give you congruent angles, or that's what you're looking for, at least. Parallel segments or parallel lines will never give you congruent segments, but they will give you congruent angles. And so if I'm looking at these right here, which case would we maybe be working with? Alternate interior angles or corresponding angles? Alternate what? Alternate interior angles. So could I say that this angle here and this angle here are alternate interior? And why can I say that those are alternate interior? Okay, what lines? Okay, can I say that those two are alternate interior because the left side is parallel to the right side? No, because remember, your angle has to touch the parallel side. And neither of these angles are touching the left side. And neither of these angles are touching the right side. But because of the second statement that the top is parallel to the bottom, then yes, we can say they're alternate interior, because now those two angles are touching a parallel side, and they're both touching a same, in this case it's a diagonal, but it'd be a transversal. And so yes, those are alternate interior, and we can say they're congruent. Are there any other alternate interior angles in this picture? Which one? Angle A and angle C. So right here and right here would be alternate interior. So if they're alternate interior, then two things have to happen. They have to touch a parallel side. Do they do that? Yes. And they have to touch the same segment, the same transversal. Do they both touch the same transversal? You know what I mean by transversal? Or do those angles touch a common line segment? Which one? So give me a line segment that they both touch. Oh, and just one line segment. Just one line segment. Can you give me one line segment that both those angles touch? Because in the other case, I can give you, see the first two, I could say both those angles are touching BD, right? But you can't do that here because they're far away from each other. So we don't have alternate interior there because they're not touching the same line segment. But there is another pair. Yeah, Sean. ABD right here and C right here. Okay, both those are touching a parallel side, and they're both touching a common line segment, BD, which is your transversal. So there we have our alternate interior angles. So being able to see that is important. All right. Is there anything else in this picture that is important? Luis? Yes. Why are these two triangles congruent? What's our reason? What's that? Oh, so well, when we talk about triangles congruent, you pick from the list of 5 things: side, 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 side angle, side. Which of those 5 reasons do we pick for why these two triangles are congruent? Angle, angle, side. Let's check that one. So remember when I talked about the difference between angle, angle, side, and angle, side, angle? Do you know the difference between those two? One of them has an S between two A's, meaning one of them has a side given between two angles. And the other one has the two angles, but the side is not in between the two angles. So in this case, which one do we want to work with? Angle, side, angle. Okay. All right, so we want to get that there. Most of the left side's done for us. What's the first reason given? Second reason? What's that? Alternate interior angles are what? Are congruent. That whole statement there, you can abbreviate like I'm abbreviating here, but you want to mention all that. And you can only mention that if somewhere in your proof before that it mentions that you're working with parallel stuff. And we do, we mention it in step 1. So step 1 tells us we're working with parallel things, so that's why we can work with alternate interior angles. Why is BD congruent to itself? Reflexive property of what? Of congruence. That's from proof tip number 1. And that does not rely on anything in our proof. That comes straight from our picture. And then we said their triangles are congruent by angle side angle congruence. And we see that in steps 2 and 3. Because steps 2, you have the angle and another angle. In steps 3, we have the side. And triangle ABD is congruent to which triangle? CDB. And we got our proof complete. Okay. So I'm going to have you guys try one a little bit without me. Let's do number 3 together. Well, do 3 first, and then I'll go over it with you. But see what you can do with number 3. No. So in thinking through why these two triangles are congruent, what is something that we know is congruent? So we go to the pieces, right? There's 6 pieces that we can choose from, side lengths or angles. What is congruent to what in terms of the pieces of the triangle? Yeah. AB is congruent to BC, and that comes from what? B is the midpoint of AC. That's the middle. That's a great first one to jump after, right? Then they tell us BE is parallel to CD. So BE right here, these arrows, is parallel to CD. It doesn't mean that they're the same length. It just means that they're going in the same direction. And when you have parallel, it doesn't give you congruent segments, but it can give you a congruent angle. So because BE is parallel to DE, can you tell me one angle is congruent to another? And if so, which angle? Looking for some yes. Okay, angle AB right here. Sorry. Say it one more time. ABD. Oh, I'm sorry. AEV right here. This one. And this one? Okay. And why? Okay. Because they're corresponding angles. Now, I want to bring you back to one thing I said up here. Okay, so angle 1 and angle 6 are corresponding. And corresponding angles two things have to happen. And this is similar with it's similar to the alternate interior. They both have to touch the parallel. And then they both have to touch a common segment. So let's make sure we have that here. So E and D, they both touch a parallel, yes. But do they both touch a common segment? So because it doesn't have that second part, we can't do that. And so I'm glad you chose it because it's a tempting to do. Right here and here. Do they both touch a parallel? Do they both touch a common segment? The bottom, right? So yes, and those are congruent because they are corresponding. And then it also tells us that AE, I'll use 2 arrows now, is parallel to BD. Can we get a congruent angle from that pair? Looking for new people. Let's maybe someone from this group here. Rowena, you see something? If you don't see it, it's fine. You say, no, I don't see it. This one here, EAB and DB, those two? Okay. And because corresponding or alternate interior? Corresponding. Do they both touch a parallel and they both touch a common segment? Good job. Okay. So why are these two triangles congruent? What's our reason going to be? Yeah. Angle side angle is what we're after. Okay. So now we're ready to start our proof. Okay, that's the thinking that has to happen before you get to writing your proof. Now we always start our proof with the givens. EE parallel to CD. AE parallel to BD. B is the midpoint of AC. And the reason's always given. Okay, so that's how we start. We know we have a little freedom in how we go in between. I'm just going to go kind of in the order we did. We said that AB was congruent to BC. And the reason was, I heard midpoint, but what's the formal reason that we got to write out? Not reflexive. Reflexive is when it's like the same segment equal to the same segment. Like if I had AB congruent to AB. It's not reflexive. Definition of, what'd you say, Lex? Definition of midpoint. Good. And that comes off of proof tip 3. Okay. Then we start talking about angles. We said angle ABE is congruent to angles BCD. And what was the reason? Corresponding angles are congruent. Sorry, I don't need that apostrophe. I'll leave it there. And then we also had the same reason for the other pair. So we could also say that angle A is congruent to angle DBC. And for the same reason. So we could squeeze them both in step 3. If you don't want to, you can make a new step. You could do step 3 and step 4, but then you have to write another reason. Notice for angle A, I'm only using one letter. And that's because it's obvious what angle A is. I could use 3 letters, but you can always use 3 letters. But you can use one letter only when it's obvious that that's the only option there is, okay? And then we have enough info, so we can say that triangle EBA is congruent to which triangle? DCB. And we said angle side angle congruent. And that relies on steps 2 and 3. Step 3 relies on step what? 1. Step 2 relies on step 1 as well. Okay. And there we have our proof. Okay. Let's go to the next proof tip. Perpendiculars. Okay. And there's really 2 things in here that I just want to mention. First of all, definition of perpendicular. And perpendicular, the symbol is like an upside down capital T. Okay, that means perpendicular. And the definition of perpendicular is that perpendicular segments form right angles. This first sentence right here. Okay. But then there's another statement that's a theorem, and that's that all right angles are congruent. It's something that we know is like obvious, but it's just a statement that we can use. So there's actually 2 statements in our proof that we could use. We can use definition of perpendicular, and we can use all right angles are congruent. And I'm going to demonstrate that with you in number 3 here. Okay. So number 3, we have AC is that upside down capital T means perpendicular to CB. And so I'm going to put a little 90-degree angle there. AD is perpendicular to DB. I'm going to put another right angle there. And AE is congruent to BE. That's the given. I'll write that out. Okay. So then I need to pause and just think, why are these triangles congruent? Okay, we also have vertical angles in here. That's important to notice. But why are these triangles congruent to each other? Angle side angle, I heard. And so, or is it angle side, right? The difference is angle side angle. You look at the 2 angles. Do we know the side in between those? No, we don't. So we don't want to go with that one. we know a side that's not in between them, and so we go with the angle on the side. So that's what we want to do. All right, so then we write this up. So how do we write this up? What do we have? We want to go angle, angle, side, and we have already the side. So in our proof we need to state two more statements for angles. What's one thing we could put in our proof? Angle what is congruent to angle what? A what? So angle C is congruent to angle D? Okay. Now, I agree. They're both 90 degrees. That means they're congruent. But in order to get that, you can't jump straight there. Because we have to work with what we're given. We're given that we have perpendicular. What's the definition of perpendicular? Is it that they're congruent? Perpendicular means that they form right angles. So we have to hit that first. And then once we get right angles, then we can say all right angles are congruent. So there's two steps here. And that's the new part right here. So if we want to do that, here's what we do. We write angle C and angle D are right angles. And the reason is the definition, that's what it means to be perpendicular. The definition of perpendicular is our reason. That's why they're right angles. Then, once we've established that they're right angles, then we can say they're congruent to each other. So angle C must be congruent to angle D because there is a theorem out there that we didn't prove in this course, but previous course, that all right angles are congruent. And now we have our congruent statement. So we've stated that an angle is congruent to an angle, so we have an A. We just need one more statement to get what we want for angle, angle, side. What else do we have to say is congruent to what? Angle AEC is congruent to angle BED. Why? Vertical angles are congruent. All right, so now we have our third statement that we need, and now we can finish our proof with statement 5, saying the triangles are congruent. So triangle BDC is congruent to what triangle? Oh, that's BDC. That's wrong, huh? Should say BDE, because BDC is not a triangle. Go to BDE. BDE is congruent to which triangle? ACE. And we said because of angle, angle, side congruence. And now last piece is what steps are relying on what steps? So step 5 relies on what steps? 1, 3, and 4. Okay. Does step 2 rely on anything? Yeah. Step 1. Does step 3 rely on anything? Step 2. Does step 4 rely on anything? No. Step 4 comes straight from the picture. Okay. So the new part here was really how do we go from perpendicular to congruent angles? And so we had these step 2 and step 3 to do that. Let's go look at number 1. AB is perpendicular to DC. BC is congruent to AC. So I know there's stuff written down in the proof, but try not to look at that right now. It's okay if you look at it, but why would these triangles be congruent? Or is there any other missing pieces we need here? What's that? Okay. What's missing? What else do we, yeah. CD is congruent to CD. Okay. And so do you guys see why those triangles would be congruent? We're working with right triangles. It states it in point 4. It says hypotenuse leg, right? Because they're right triangles. And in your proof, to prove some hypotenuse leg, you have to have 3 things. You have to have hypotenuse congruent to hypotenuse, leg congruent to leg, and in your proof it has to say that you got right angles. You don't have to say the angles are congruent to each other. You just have to say they're right angles. That allows you to use hypotenuse and leg. Okay. So our given is AB is perpendicular to DC. BC is congruent, not perpendicular. To AC. And then we got to work with the way they ordered it. All right. So number 2 says definition of perpendicular. So what would we write for number 2? Angle ADC is, can I say it's congruent to BDC? No, because that's not the definition. So angle ADC and angle BDC are right angles. That's what you want to put there. And then reflexive properties, so that's going to be what? Is DC congruent to DC. And then you finish off your proof with triangle BDC is congruent to triangle ADC. All right, so that's where I want to stop. Homework again is to finish all of parallel and all of perpendicular, so that's proof tip 4 and proof tip 5.